Hi everybody, Mr. Clark here again. Well, let's continue with multiplying polynomials. So today we're going to do the infamous binomial times the binomials. So I may went up here. So you can see the orange is two terms, that's a binomial, x plus 5. And then the x minus 3 in the blue, that's two terms, so that's a binomial. So if we're going to multiply these together, we're going to use the double distributive property. Well, that's not an official math word, but I think you'll be able to figure that out by looking at what I've done here. So I've taken the x and I've multiplied it by the x minus 3 right there. And then I just continue down. I got the positive 5. And I multiplied the times the x minus 3. So I kind of broke it up into two parts here. Split this guy in half. And multiplied each part by the x minus 3. Now it's very simple. We're going to use the single distributive property twice. So we've already done the single distributive property. Just multiply that through. So I'm going to just take this here. Let's say x times x right there is x squared. And then I'm going to have x times a minus 3 to minus 3x. And I'm done with him. So I'm just going to go over here to the positive 5. Positive 5 times x. Positive 5x. And then the positive 5 times the minus 3 is minus 15. All right, so now I've used the single distributive property twice. So now I look here and I look for like terms. And so I have these here together in this light green here. Looking for the same power, same variable with the same power. And of course I have it right here, 3x and the 5x. Those are like terms. So I have to combine those two together. So I've taken this and I said, oh, but 5 minus 3 is what? 2x. And so the answer is just x squared plus 2x minus 15. All right, so we have a binomial times a binomial, and so we have two terms, right? X plus 5 is two terms, and x minus 3 is two terms. And then we use this so-called double distributive property, in which I kind of broke up the term on the left, the orange, and multiplied each part times the x minus 3. And then I used the single distributive property that we learned before, and I got x squared minus 3x plus 5x minus 15. And now I look around and see if I can find some like terms, and I did. I saw that the minus 3x plus the 5x, those are like terms. Same variable with the same power, so I said 5 minus 3 was 2x. So that's the general procedure. So let's try a more complicated example. But here I have a more complicated example. Just have a little more x's in there. So I have 3x squared minus 5x. There's my binomial on the left. And then I have 4x plus 2. So we're going to do the same procedure as we did before. Use that double distributive property. If we do that, that yields. So again, I'm going to break this into two parts. I'm going to take the 3x squared and multiply that times 4x plus 2. And then I'm going to go minus 5x times the 4x plus 2. So now I have a pair of single distributive properties. I'm going to use it twice again. So I'm going to say 3x squared times 4x. So you got to multiply the whole numbers together. 3 times 4 is 12. Here's my 12. And then I have x squared times x. So that's 3x's there. So I have x cubed. And then I have 3x squared times a positive 2 is 6x squared. I'm done with him. I can focus over on this part here. Uh-oh, got that minus. I got to watch out for that. It's a minus 5 times 4. It's a minus 20. And I have x times x is x squared. And then I go down to the last term. Minus 5x times a positive 2 is a minus 10x. All right. So what do we got to do? Well, it's like terms again. So I have these like terms here in the light green here. So the x cubed doesn't have a buddy. I copy him over. These two, I have 6 minus 20. It's minus 14. And then finally, the minus 10x. He doesn't have a buddy, so I just copy him over there. And yellow is the answer. So I did another example, a little more complicated. Got some higher powers here, so you got to watch out. We got to use the addition property of exponents here. And so, see, I went up to an x cubed here. So I had 3x squared times 4x, so that was a total of what? X squared times x is x cubed. And then I had the 3 times 4 was the 12. But otherwise, it's pretty much the same. You just got to watch out sometimes. You have to be careful with the addition of property of exponents. All right, well, let's try you try. You try a few of those. Some of them are simple, some are a little more complicated. Try number 1, please. Thank you. All right, so let's try this first one. What's the answer to the first one? There it is. So that's just, x times x is x squared. And then I'm going to have x times 5 is 5x. And then I'm going to have a 1x. It's going to give me a total of 6 x's. And 1 times 5 is 5. Right. Try the next one. Looks pretty much the same level of complexity. All right, so the next one is almost the same answer, except I have a negative 6x. This is a little tricky here, so I have x times x is going to be, if you break that up, it's x squared. Then I'm going to have a minus x, and a minus 5x is the minus 6x. But if you notice, when you broke this up, you had a minus 1 times a minus 5, and you had to have 2 minuses is a positive. Okay. All right, let's try the next one. Yeah, this was a little more difficult. I got more higher powers in there. Same principle. Just count your powers. All right, here's the answer here. Now, this one's interesting. There's no like terms if you actually tried to work that out. So I have x squared times x cubed. 2 plus 3 is 5. I didn't get any more x to the 5th. And then I said x squared times minus 5x squared. So that was minus 5, and 2 plus 2 is minus to the 4th. All right, and that was the first part of the distribution. Now I'm going to work the 3 of 3 times x cubed was 3x cubed. And then the last one was 3 times minus 5 is minus 15x squared. So that one actually didn't have any like terms. They were all different powers. Same variable, but it had different powers. All right, try the next one. I don't know why I made the next one up. It's tricky. It took me a second. Hard to explain without pencil and paper. All right, what's this one? Wow. So it's only three terms. So if I do the first one, I have x cubed times x squared is x to the fifth. I look over here, I got an x to the fifth, but wow, I got a minus 14. So there must have been another x to the fifth. Well, I had this right here. I had the minus 5x squared times the 3x cubed. So 2 plus 3 is 5, and that was a minus 15. Plus the 1 gave me a minus 14. Okay, and then the rest they have no buddies. They just appear. I know that's tricky. The next one, important case, it's a difference of squares. You can do that one. So when they look exactly the same, but the sign's different, something cancels out. So we'll do special cases, probably next video will be special cases of binomial times a binomial. Okay, and so this one is just x squared y squared minus 25x squared. So it turns out to just be the first guy squared. So if I square xy, I get x squared y squared, and then I just get minus the last guy squared, which is 5 times 5 is 25 and x squared. We'll do special cases on our next video. All right, so there's that. Now you know what time it is. What time is it, you say? Well, it's time for your homework. So 7 here, but a lot of them are pretty simple. I have a lot of difference of squares here. Okay, very important. There's just a trick to doing that. And then a couple little complicated ones, a couple regular ones, not too difficult. Should be able to do those. And, 15 minutes. All right, well, thank you for watching my video. Stay safe and be healthy. And I will see you next time. Make sure you try to turn this in Google Classroom. And remember, if you're having trouble with the Google Classroom, just email me your answers, okay? So everybody's getting credit for this. If you're worried about your grades, send me an email. That's fine. I'll let you know. Thank you.